Hey guys, today we are looking at our notes for 1.4, which is all about multiplying and dividing fractions. So this is our last set of notes dealing specifically just with fractions. Today, obviously, then focusing on the operations of multiplication and division. Now this is also our last section before we do our first quiz this chapter. So after this lesson, we'll have a day of review, and then we'll be taking our quiz the following day. So getting into multiplication and division, I think this is actually a little bit easier than what we did yesterday. In 1.3, we talked about adding and subtracting fractions. You had to get a common denominator for that. That's not the case when we're multiplying or dividing them. When we're multiplying fractions together, all we have to do is multiply our numerators together and our denominators together. Now that's obviously an oversimplification. Taking a look at our steps here, first we need to make sure we have improper fractions. We just want one numerator, one denominator. So if we have a mixed number, we're just going to rewrite it as an improper first. If we can simplify, we can do that. We can do that both within a fraction or within the same fraction or across my two of them. So when I'm talking about reducing, I can divide top and bottom by something to make it simpler. And then we're going to just multiply across. Numerator with numerator, denominator with denominator. Now, you could, if you wanted to, if you don't like the idea here of simplifying beforehand, you can just do kind of skip step 2 and just do steps 1, 3, and 4, where you make sure there's single fractions, you multiply across, and then you simplify at the end. That still will be perfectly fine for you. So if we go ahead and jump into some of the examples here, today I'm going to do the odd problems with you, and then as usual, if you want to pause the video and try the evens, I'll give you the answers once we're done with that section. So with number 1 here, if we're multiplying 1/2 times 4 over 5, they're already both just single fractions. They're proper fractions in this case. So all I have to do to multiply these together, I just multiply straight across. Our numerators get multiplied together. 1 times 4 is 4. My denominators get multiplied together. 2 times 5 is 10. So that was step 3. My last one, step 4, reduce as needed. So simplify as needed. So in this case, both 4 and 10 are even. So I'm going to go ahead and divide top and bottom by 2 to give me 2 over 5. And that should be my final answer. 2/5 is my final answer once I multiply. Okay. Number 3, I've got 1/7 times negative 1/5. Now, I have to be careful here because my rules that we talked about when we were multiplying numbers together back in, I think it was 1.1, our very first section, multiplying integers together, we have a positive times a negative. That still means our answer is going to be a negative number. So we can just handle that separately and just say, okay, well, I know it's going to be negative because I had a negative involved. And then the rest of it is still the same rules as we had before. Numerator times numerator, so 1 times 1 is 1. Denominator times denominator, 7 times 5 is 35. And there's nothing in common between 1 and 35 besides 1. So that is my answer. That's all I have to do there. Negative 1 over 35. All right, last one in this section here. Number 5, we've got negative 1 1/3 times 1/2. So we do actually have to do something for step 1 in those instructions that we were given. First things first, we have to convert that negative 1 1/3 into a improper fraction instead of a mixed number. So remember our process for doing that. I'm going to multiply my big number times my denominator. So 1 times 3 is 3. And then add my numerator, which gives me a negative 4 over 3 times 1/2. So something that you can do, this is what step 2 is describing to you. Instead of having to write out what I'm dividing by on both top and bottom, so here for number 1 that we did, we recognized that they're both even numbers, so I reduced by dividing by 2 on both top and bottom. Another way that you can do this is by kind of canceling them out. If you have two numbers that are going to reduce on both top and bottom, you can kind of just cross them out and reduce them to what your answer would be after you divide. So what step 3 is telling us is, since eventually we're going to multiply these across, numerator with numerator, denominator with a denominator, if you have numbers that can reduce on both top and bottom, even if they're in separate fractions, you can reduce them. Like here, my 4 and my 2, I recognize both of those are even numbers, so I can reduce both of them before you multiply across. That's going to make your life easier when you reduce at the end. So here, if both of those are divisible by 2, if I divided 4 by 2, I would get 2. If I got 2 divided by 2, that would leave me with a 1. So I'm just crossing out those numbers and rewriting what they reduce to at the end. Because then I can go ahead and multiply straight across. My negative is still going to be there because I had one negative. Up top, 2 times 1 is 2. 3 times 1 is 3. And that would be my answer. If you didn't like that and you don't like doing it that way, again, we can still do it the way we did it before. 4 over 3 times 1 over 2, negative. You can still multiply first, negative 4 over 6. And then just reduce at the end. We recognize 4 and 6 are both divisible by 2. So if you want to do it that same method that we were doing it, negative 2 over 3 is still my final answer there. Either way you want to do it, go ahead. All right. With the evens, if you wanted to try them on your own, go ahead and pause the video, do those 3 problems, and then go ahead and hit play and check your answers. For number 2, you should get 1 over 15 after you reduce. Number 4, you should get either 11/3 if you leave it improper, or 3 2/3 if you make it a mixed number again. 6 shouldn't be that different from number 5, but be careful here because we are dealing with 2 negative numbers, and we know that if I have a negative times a negative, it's going to get me a positive solution. So number 6, my answer is 28 over 15, positive. Or if you put it as a mixed number, 1 and 13/15. Okay. All right. Dividing our fraction. So here, kind of the bottom of the front goes into the top of the backside. So when we divide fractions, it's very similar to multiplying with one extra step. So you can see here in step 2, before we multiply, so after we're still going to start by making sure it's just a single fraction, either proper or improper. We don't want mixed numbers. But when we multiply, or when we divide something, that's the same thing as multiplying by its reciprocal. So you might have heard that word before. Reciprocal is just a very fancy way of saying I flipped my fraction over. So the reciprocal of 2 over 3, I just flip it over, 3 over 2. So instead of saying it's division, we're just going to do the reciprocal, and then it turns to multiplication. In which case, we already did some practice problems with multiplication. Same rules apply once you're starting to multiply. Okay, so let's go ahead and flip on over for you guys on the back side. Again, we're going to do the odd problems. So for our examples here for number 7, we have 1 over 6 divided by 1 over 5. So they're already single fractions, which is nice. So to be able to handle this, I'm going to flip over the second fraction, and then it becomes multiplication. So 1/6 divided by 1/5 is the same thing as 1/6 times 5 over 1 instead of 1 over 5. Because, again, I'm reciprocating just the second fraction. My first one I stay the same, the second one I flip. And now that it's a multiplication problem, we know I can multiply straight across. 1 times 5 is 5. 6 times 1 is 6. So 5 over 6 is my final answer there. Okay, flipping on, or continuing, not flipping, continuing down to number 9. Negative 4 over 7 divided by negative 8 over 9. So they're already individual fractions. If I flip to multiply, negative 4 over 7 doesn't change. That becomes times negative 9 over 8. So you can see I'm just flipping my second fraction over. Numerator becomes denominator, denominator becomes numerator. And now from here, I can just multiply straight across if you want to. It's going to be up to you on how you want to do that. If you're a person who wants to reduce right away first, we see that 4 and that 8 that are going to reduce eventually. But in case you don't see it, let's go ahead and pretend we are going to just do it the old-fashioned way. I do also have two negatives multiplying together, so I know it's going to be positive. So 4 times 9 is 36. 7 times 8 is 56. So here, once you do that division, once we've done that multiplication process, now I have to reduce. 56 and 36 are both divisible by 4. So my final answer here should be 9 over 14. 9 over 14. Okay. Last one here before we do an application problem. So number 11, we have two mixed numbers. So first things first, we're going to make them improper fractions. So if I do that, 4 times 7 is 28, plus 2 is 30. So negative 30 over 7, divided by 1 and 1/3. Let's see, 1 times 3 would be 3, plus my 1 up top gives me 4/3. So that's what my division really is. Negative 37ths divided by 4/3. So we know if we're going to do division here, my first one stays the same. My second one gets flipped over. So now that I've flipped both of those, negative 30 over 7 times 3 over 4, when I flip the second fraction over there, now I can either reduce if you want to. We see it's usually a little easier to recognize what you can divide by, top and bottom, to reduce. But 30 and 4 are both even numbers, so you can divide both of those by 2. 15 and 2. And that looks like about all we can do. So then I can go ahead and multiply straight across. 15 times 3 is 45. 7 times 2 is 14. 1 was negative, 1 was positive, so my answer should still be negative. So negative 45 over 14, or if you're going to be a mixed number person, negative 3 and 3/14. Okay. Once again, if you want to practice those even problems, go ahead and pause the video, try them on your own, and then check your answers here. Number 8, you should have gotten negative 3 over 2, which is negative 1.5 as a mixed number. Number 10, you should have gotten negative 3 over 4. And then number 12, 11 over 20, positive 11 over 20. Okay. For our last two problems, we've got some different applications of multiplying and dividing fractions. So in this first one, the Statue of Liberty is 305 feet tall. A nearby building is 4/9 as tall as the Statue of Liberty. We're asked to find the height of a building. So if you're trying to figure out how tall this is, we would multiply the height of the Statue of Liberty times 4/9, because if the building is 4/9 as tall, I multiply those two together, and that's going to give me the height of that building. So setup-wise, we would have 305 times 4 over 9, which, if we do that, we can, if it's a whole number and you want it to be a fraction, you would just multiply by, or you would just put it as a fraction over 1. So if that's the case, when we try and evaluate this, we try and multiply these together. Numerator with numerator, 305 times 4. I would have a calculator for that. I'm not going to try and do that in my head. I mean, I could if we wanted to, or you can use scratch paper if you really want to, but 1,220. I would suggest using a calculator for that. And then that's still over 9. So you can leave it that way, or you can put it as a mixed number. So if you're going to do it as a mixed number, the way that you would do that, you would take 1220, so 1220, divide that by 9. It'll tell you exactly how many times it goes into 1,220, which it goes into it evenly 135 times. But if you do 9 times 135, it's only going to give you 1,215, which means there's 5 more left over. So 135 and 5/9 feet. Again, I'm fine either way. If you like it as a mixed number, knock your socks off. If you feel like it's just unnecessary extra steps, I'm fine leaving it as a fraction, an improper fraction. Just make sure either way you list it, you include feet in your answer, because we're once again working with an example problem that has units given to us, so units have to be given back out. All right. So for number 14, our very last one, Sarah has 27 3/4 feet of wire to make bead necklaces. If each necklace requires 1 2/3 feet of wire, how many necklaces can she make? So a similar problem here, we have to use division, because if you had, I don't know, a foot, if you had 12 inches of string and you were going to make something with it that is 3 inches each, you would just divide how much we have by how many is necessary for each one. So in this case, we're going to take that length of the wire, 27 3/4. Let's write that down. Keyboard go away. So 27 3/4 is going to be divided by 1 2/3. Divided by 1 2/3. So first things first, convert those into mixed numbers. 27 times 4 is what, 108? Yeah, 108. Plus 3 would be 111. Use a calculator. You don't have to struggle like I did just now. And then 1 times 3 is 3, plus 2 is 5. So 111 over 4 divided by 5/3. So we know if we're doing division, we just multiply by the reciprocal. So 111 over 4 times 3 over 5. And then we can just multiply straight across. So 333 over 20. So now, if I can't leave it as an improper fraction, because the question they asked me was, how many necklaces can she make? And she can't make 333/20 necklaces. We have to figure out how many total necklaces she makes. So we can use our calculator for this to do division, but we have to be careful, because in this case, we end up with 16 and then some extra left over. In this case, 13/20. But she can't make 16 13/20 of a necklace. So we would have to conclude that she can make 16 necklaces. She doesn't have enough to make 17, so 16 is all that she could make. Alrighty. That's it for this section for 1.4. Again, this is the last topic before our quiz, our first quiz for this chapter. So our next tomorrow probably, or depending on when this falls notes-wise in terms of days of the week, our next day will be a review day, and then we'll be taking our quiz after that. So, as always, if you have any questions, concerns, thoughts, ideas, hopes, or dreams, make sure you guys are reaching out and letting me know. Otherwise, have a fantastic day. We'll see you soon.